Welcome to another Dr. Z video. Today, as always, we are following the Cambridge Science textbook and we are focusing on the topic of our place in space. Don't forget to comment on anything you are struggling at with school so that our team can help. So, here are today's outcomes. Some you may be familiar with, others not. Anyways, let's get straight into it. First, we have to describe the inner structure of the Earth. The Earth is composed of 4 distinct layers. The inner core. Now, the inner core is in the center and is the hottest part of the Earth. It is solid and is made up of iron and nickel with temperatures of up to 5,500 degrees Celsius. The outer core is a layer surrounding the inner core. Now, it is a liquid layer and is also made up of iron and nickel. It is still extremely hot with temperatures similar to the inner core. Then there is the mantle. The mantle is the widest section of the Earth. It has a thickness of approximately 2,900 kilometers. The mantle is made up of semi-molten rock called magma. In the upper part of the mantle, the rock is hard, but lower down the rock is soft and beginning to melt. And finally, we have the crust. The crust is the outer layer of the Earth. It is a thin layer between 0 to 60 kilometers thick. The crust is the solid rock layer upon which we live, and the solid path of the Earth's crust is known as the lithosphere, and you can see the lithosphere here. So this diagram again is a useful aid for you to use when taking down notes. But what exactly are rocks made of? So rocks are made of substances called minerals. Minerals are naturally occurring inorganic solid. They have a definite and consistent chemical composition and an ordered atomic arrangement. To put it simply, they are not man-made, they have not come from living things, and they have an exact mix of chemicals that are composed in a particular way. Now, these chemical substances, which make up the minerals, can take the form of chemical compounds or can be found in their pure form. Whilst it is hard to find elements in their pure form in nature, gold, up here, and diamond are 2 such examples. Okay. Sedimentary, igneous, and metamorphic rocks. That's the next thing we have to cover. Sedimentary rocks are formed from grains of sediments or particles that have been compressed, like mud or sand settling at the bottom of rivers or oceans. Now, in terms of the characteristics, they can be identified through the following traits: the presence of grains and sediments, wavy layers, and perhaps the presence of fossils. Now, there are many examples of sedimentary rocks, but the one on the right here is coal, which is one such example, and there's also others including sandstone, limestone, and shale. Then there are igneous rocks. Now, igneous rocks form when magma and lava cool and turn into solid rock. They are generally hard, possess crystals, have a glassy surface, and are dense. So on the right here, you have one example of an igneous rock known as obsidian. Other examples include granite, basalt, and pumice. Finally, there are metamorphic rocks. Now, these are weird to characterize, but they are formed by changing already existing rocks through extreme heat and pressure. So as a result, it's really hard to characterize these rocks under neatly identifiable boundaries. But examples like the one on the right is like marble, and there's also quartzite and slate. So, let's talk about the breaking down of rocks, which is known as weathering. So, there are 2 main types of weathering. Firstly, physical weathering. This is where the breaking down of rock is caused by physical changes, such as changes in temperature, freezing and thawing, and the effects of wind, rain, and waves. The rock is broken through the force of other substances. Now, a prime example of this is the 12 Apostles in Victoria, where the action of the sea breaks pieces of coastal rock, which produces this quite good-looking landmark. Then there is also chemical weathering. This is where the breaking down of rock occurs when reactions between rock and another substance dissolves the rock, therefore causing parts of it to break off. Now, chemical weathering alters a rock's chemical composition. And you can see on the right here, this is an example of chemical weathering. So there are literally holes in the rock. So, now the final thing we're going to look at is how exactly do fossils form. But firstly, what are fossils? Fossils are the evidence of living things preserved in rock, ice, etc. They are formed from the remains of plants or animals, known as organic matter, which have died and become buried in sediments before they could decay. Now, the fossils form through the following process. Firstly, the remains of the animals or plant are buried in sediments. Now, if they die near a muddy swamp or shallow lake or riverboard, they remain sunk in the mud and then washed into a river in a flood, and these bones are quickly buried in sediment. Remember that one condition for the formation of fossils is that there is a rapid burial. Then, more layers of sediment are deposited on top of the buried remains over time. Again, here we're going to introduce two conditions for fossils to remain. First condition is that the buried organism must not be disturbed. And secondly, under step 3, the lack of oxygen means that the bacteria cannot break down the organism. So those are other conditions for rocks to form. And then finally, the layer of rock containing the fossilized remains are pushed upwards and bent and tilted by forces beneath the Earth's surface. Weathering and erosion by the wind, sea, rivers, or glaciers might expose one or more of the bones, and if paleontologists discover this, then it can be useful for their study. Okay, again, thank you guys for watching. Please like and subscribe and comment down below on anything we can address to help.